ask for a GCF. M can be factored out. We see 2m squared minus 5m minus 12 left over. We try to factor it further. We know that it's got to be a 2m in one parentheses and an m in the other. Then we play with the numbers, and I see that 3 and 4 are going to work, especially if I have a positive 3 and a minus 4. Notice how in the center I have a 3m, and on the outer edges I'd have a minus 8m, and together those would make the minus 5. So our three solutions in this problem are 0 coming from that m out in front, negative 3 halves coming from the first parentheses, and positive 4 coming from the third parentheses. The next problem is already factored for us. That 4 out front we're going to ignore, and we're going to have three other solutions. 1/2 coming from the first parentheses, positive 10 coming from the second parentheses, and negative 7 coming from the third. Once you get used to factoring, these will become pretty quick and easy for you. We're going to factor a common factor of 2y out of each of these terms, leaving us with y minus 10. When there's a 2 in front, we ignore it, but the y gives us a solution of 0. Changing the sign from the minus 10, we have positive 10. And there are the two solutions. Okay, a few more of these to go here. 9n squared equals 1. Yeah, you could square root both sides, but we get into some trouble there. Instead, I suggest that we set this equal to 0, then factor using the difference of two squares, 3n plus 1, 3n minus 1, and then we have our two different solutions, plus or minus 1/3. Okay, now let me just make that comment about square roots. If you were to have said 9n squared equals 1, and then you wanted to square root both sides and say, 3n equals 1, divide by 3 and get 1/3, you've got a little bit of a problem here, because you're about to get one answer and I had two over there. Technically, there's absolute values around that 3n. The removal of the absolute value gives you the plus or minus 1, and then dividing by the 3, there's your plus or minus 1/3. Because of the absolute values, I really tend to not suggest this approach when you've got this nice neat difference of two squares approach to take on this problem. Continuing on. This next one is not set equal to 0. So I'm going to add 20y to both sides, bringing that 20y to the left and setting it equal to 0. That will give us 2y to the third plus 14y squared plus 20y equals 0. We can factor out a common factor of 2y, leaving y squared plus 7y plus 10. Leave the 2i out front, factor the remaining expression into y plus 2 times y plus 5. And then finally write your solution. The 2y, we ignore the 2, the y gives us a 0. The first parentheses gives us a negative 2. The second parentheses gives us a negative 5. We begin by distributing the 3z across the parentheses. This is going to give us 3z squared minus 6z minus z equals 3z squared plus 4. At which point we notice this is quadratic, but it turns out the 3z squares, when you try to bring them all to the left, cancel each other out. And that just leaves us with the 6z minus the z, which combine together to be minus 7z is equal to 4. And then dividing each side by negative 7, we have z is equal to negative 4/7. Okay, this next one is factored, but we don't have an 18 product rule. We only have a 0 product rule. So we're going to have to FOIL together what we see on the left for starts. First term x squared, outer plus 2x, inner minus x, last term is minus 2, and I'm going to already subtract that 18 to the left hand side because we're going to have that baby set equal to 0 as soon as possible. Now we combine like terms. X squared plus x minus 20 equals 0, and then factor x plus 5 times x minus 4 equals 0, giving us the two solutions of negative 5 and positive 4.